Dip from what?
Of the horizon.
From the horizon?
Yeah, the thing apparently
from the horizon.
Yeah.
From the horizon. And is the horizon capable of deriving an angle from, i.e. it's geometric with a straight line to it, or is it refracted?
Yeah, it is refracted.
Well, then refracted means deviated from straight. You're not going to be correcting any angles from a deviated from straight line. That would require a straight line. So if the horizon's refracted, why are you correcting dip from it? It's not a straight line to correct from.
Yeah, but that's not exactly how you measure.
It's not a tangent.
It's
sextant, not right? A tangent, is it?
At the sextant, it is.
So, sorry, the sextant, according to you, is looking at the horizon, and according to you, that's refracted, i.e. it's geometric with a straight line to it, or is it refracted?
Yeah, it is refracted.
So no,
yeah.
According to you, it is not a tangent, so you do not have a tangent.
Globe is dead, right? The only way you can resurrect it for all of us here is to show how you can obtain an elevation angle from a curved baseline. Can you do that?
Yeah, I don't think the elevation angle is from the curved baseline.
You don't think an elevation angle is from a curved baseline? You're correct. That equals your globe's dead.
But how would we get elevation angles from Earth then if Earth is supposed to be curved?
What an idiot.
Well, it depends on what tool you're using.
We're using a sextant.
Right. So you measure an angle from the horizon, which is not yet an elevation angle. And then you correct for a dip, and that's your elevation angle.
Really? Define it.
Define the elevation angle?
Yes.
Oh, it's the angle above horizontal.
Is that it?
Horizontal.
Define dip correction. Hang on. Define.
No, hold on. No, not dip correction. No. Define elevation angle. I need a citation here, not what you just made up.
Well, he said it was the angle taken from horizontal. Is that what you said, Bacon?
Yeah, that's what I said. Yeah.
So not taken from a curve then?
Yeah. No.
So welcome to Flat Earth.
Why?
So you're under the misapprehension the ground's curving, Bacon. You're saying that you're measuring the ground flat then?
No, I didn't say we measured the elevation angle from the ground. Remember, I said you measure from the ground, but that's not the elevation angle yet. You have to.
Excuse me. You just said I'm not telling you I'm measuring it from the ground. Your next breath was to tell me you're measuring it from the ground.
No, because I wasn't referring to the elevation angle when I said it.
Oh, my bad. Sorry. Excuse me. Pray tell. Where do you think navigation takes place? Is it taking place somewhere other than the ground? Is that not what we're navigating? Do you misunderstand what navigation is for?
Well, I think it works on airplanes as well.
So, to navigate the ground. Sorry. And are they navigating to find a cloud, or their position on the ground?
Yeah, they're finding the ground position, but they're not on the ground.
So we are most definitely in contradiction to your last statement, dealing with the ground then, because you said you weren't. You weren't. Now, obviously, you just seem to be some crazy guy who's telling us that you don't do that. Navigation, on the other hand, is specifically related to the ground, though, isn't it? Don't matter what you're doing.
Yeah, sure. If you want to know your ground position, yeah.
Right, so, and we're establishing this angle when we measure the ground from horizontal, not curving. Welcome to Flat Earth.
Snacks in the back.
Sorry, I'm not sure what your point was.
Yeah, you don't understand it. That's why.
I'll explain again. You're measuring the ground as horizontal when you measure this angle. Yes, that's what you said. So are we measuring the ground as a curved surface No, we are measuring it, quote, horizontal.
Well, if we're using the ground at like horizontal, then like why would it dip from eye
So
level?
if we're using the ground as horizontal, yeah, we are. Welcome to Flat Earth. You're going to ask me about the horizontal ground we're now going to be navigating.
You have your eye on the horizon, and you bring the celestial object down to the horizon, that horizontal plane, correct?
Yeah, exactly. No,
Okay,
no.
so
So I'm sorry. I shouldn't have agreed to that. That's not a horizontal plane.
Oh, yes, it is. That's what an elevation angle is, son.
Yeah, it would be an elevation angle if
Yeah.
Sorry, yes, it is
Oh,
then.
let
So
me
yes,
know.
it is. That's
me
what an
respond to
elevation
that.
angle is.
So, no, the elevation angle is from horizontal. If you're sighting the horizon and the
Yeah.
horizon drops, that's not horizontal, is it?
So why? So hold on. Let me just. Hold on.
Hold on.
Why is it being used then? Why do they use it then? To get an
Because
elevation
it's
angle.
the best reference you have on the ocean.
So the best reference for a horizontal on the ocean is the horizon.
Yes, which is very close to it.
And you're
you know
using
how
it
much
to,
it
and
is.
sorry, and you're using it to establish a horizontal plane.
Yes.
So the
Exactly.
horizon's the best thing you've got to establish a horizontal plane, and that is what you're using when you measure an elevation angle.
Again, you're not measuring the elevation angle.
So why aren't you? When we're measuring an
something that
elevation... Sorry. Every time we get to this point, you seem to tell me that we're not measuring an elevation angle. No, we are. That's
Not directly.
precisely what we're doing when we measure an elevation angle to do navigation with. That is what we're doing. Just because it requires a flat plane that you're establishing with the horizon, that's where we've got. That doesn't mean it isn't. It means it is.
Oh, but it requires a correction before it gets called an elevation angle, right?
Incorrect.
And what is that correct? And what is that correction? Height of eye?
Yeah.
Oh, God.
Okay, all right.
I can't
No,
win
got
with
him,
you
I got
guys.
him.
I'm serious.
Hang on. Okay, just let me have him for a minute.
Hang
So height
on.
of- Okay, forget it. My gosh, you're just not going to let this evolve.
Bitch. I'm going to fucking drop you guys.
Oh, thank you. Height of eye. So is that dip correction?
Yeah.
Okay, great. If you were on the level of the sea with the sextant and your eyeball was there, would you have to do dip correction?
Yeah.
Oh, really?
Sorry.
Can you give,
Actually,
can you give me a
maybe-
citation? Can you give me a citation that says if your eyeball is level with the sea, you have to do height of eye correction? Can you show me that, please?
Oh, no, sorry. You mean if like my eyeballs are on the... Yeah, I get it. No, you don't. You're right. You don't.
Okay, welcome
He's
to
just going
Flat
to change
Earth.
the answer every fucking
What?
time. This cunt, man.
Welcome to Flat
Sorry,
Earth.
I just wasn't clear about the question.
Yeah, you're a fucking idiot.
Why?
Yes.
Hang on. If you don't do it then welcome to Flat Earth. You got your horizontal at sea level now.
Yeah, but usually I'm not with my eye at sea level, right?
I know, but that's the
You are.
correction.
It doesn't change anything.
That's, can you please hold it for a second? It's called the angle of depression correction. So if you're on top of a boat 10 feet above sea level, you minus 10 feet so that your eyeballs are on sea level. That's the whole purpose of height of eye correction, isn't it?
Yeah.
Okay, then welcome to Flat Earth. You
Okay,
just got your horizontal at sea level, so no height of eye correction. It
Not
matches
curving.
your-
That'd be horizontal. Not curving.
Isn't
Not
that
curving.
the height of eye correction?
Hello? Not curving.
Why not curving? How does that imply not
that's
curving?
what
I don't get it.
That's what horizontal is. The horizontal. Do you not understand what horizontal means? Do you think that means curving? Are you stupid?
No.
Right.
say
So
that.
horizontal then, not curving. Welcome
Yeah,
to
but
Flat
that's
Earth, mate.
not the
Yeah.
surface.
While this sinks in,
It's just a
welcome to
horizontal
Flat
plane.
Earth. Yeah. It doesn't require a response. It requires me to laugh at you. Welcome to Flat Earth, not curving then. Like I tried to explain earlier, you talked through me then too.
Well, then why are you guys talking to me if you don't want my response?
Because you're establishing a horizontal plane when you measure an elevation angle, and then you tell me that we're not measuring an elevation
Sure, but
angle. That's what you
not
did
the
twice.
surface of the
And then
Earth. It's just a-
talk straight through the middle of me. Yeah, we are measuring an elevation angle. Last time we spoke, you told me we weren't, after we established that would require a flat Earth, because you're measuring from the horizontal. and you're using the horizon to establish it. It's the best thing we can use, according to you. But then the last interjection from you was to tell me that we weren't measuring an elevation angle. Yeah, we are. It just requires a flat Earth. I'm welcoming you to flat Earth based on your descriptions of what we'll be doing and the ground that we're establishing a horizontal with the horizon to do it with. That's a flat Earth, mate. Welcome to flat Earth.
Welcome, Bacon.
That's a
You
straw man.
have.
Because,
Sorry, you
also-
used that little nutshell too last time. You told me that it was a straw man. A straw man? What? To use your description of establishing a horizontal with the best thing we can do it with the horizon? No, that was your description. It just didn't involve curved surfaces. So, no, not a straw man. We're using what you described. Not a straw man. Hello?
Yeah, it's the wrong terminology.
Well, you are
It's
when you
not a straw
don't
man.
acknowledge
That's your
when I was referring
concession
to if
to
we
the
are.
argument.
I'm sorry, I thought no one was speaking.
Bacon, you are mixing up the current description of dip correction and the current description of height of void correction. You don't realize that currently there are two different corrections. There used to be one correction, but then when they added heliocentrism, they became two different corrections. You don't have them correct. Currently, dip correction is not height of void correction. It's a 7/6R correction, mathematical correction. You don't do it in reality. It's only a mathematical correction. You don't need to do it for the use of the sextant.
I think we might understand each other if you allow me to proceed with the bubble sextant.
Guys have
example.
to go to dip correction.
So what? Sorry.
I don't get it.
Why are we using a bubble sextant?
To clarify what I mean by the dip.
So
And
dip
see
from
if we
what?
can
So,
agree or
dip from-
disagree on-
Dip from what?
Of the horizon.
From the
Yeah,
horizon?
the thing apparently you
from
don't
the
believe-
horizon.
Yeah.
From the horizon. And is the horizon capable of deriving an angle from, i.e. it's geometric with a straight line to it, or is it refracted?
Yeah, it is refracted.
Well, then refracted means deviated from straight. You're not going to be correcting any angles from a deviated from straight line. That would require a straight line. So if the horizon's refracted, why are you correcting dip from it? It's not a straight line to correct from. Meanwhile,
So
dip correction's just height of eye
you
correction.
So you can't correct for curved lines?
Sorry, do you think
Like,
an angle
why
is
is the-
acquirable from a curved line?
How do you do the correction for refraction of the celestial body then? Isn't that also a curved line?
Sorry, you haven't answered my question. Do you think you can correct an angle from a bent line? Because a bent line doesn't give you an angle to correct
Yeah.
from.
I mean, you should think as well. Because
Sorry, why are you telling me what I should think?
there's
Just
a-
answer me. Do you think your bent line to a horizon, that's refracted,
I already
deviated from
answered it.
straight? Don't talk
Yeah.
through me. Just listen to the question and then respond to it. Do you think a line that is deviated from straight
The answer
is
is yes.
capable of... That's the third time you've interrupted me. Does this scare you? Don't seem to be interrupting me now. Does this scare you? I'll ask again. Do you believe, because you are retarded, that a bent line is capable of an angle correction? You complete moron, you idiot who can't stop interrupting me. You
Well, I said
fucktard.
it, yes,
Do you
like
understand me,
4 times.
fucktard? No, bent lines you don't use bent lines to correct angles from. That's stupid. So you told me the horizon's refracted, you won't be correcting a dip angle from that then, you stupid idiot. Didn't you understand me?
Oh, isn't the celestial body?
Why are you telling me what something
also
isn't?
refracted?
You're not acknowledging what I've just told you 3 times. You won't correct an angle from a refracted horizon. That's the 3rd time I've said it. Why are you asking me something, you stupid idiot? Just acknowledge that no, you won't be correcting an angle from a bent line.
Okay, so no correction for the bodies then, right?
Right,
Is
don't
it
tell
al-
me what there
is
isn't.
also
Just
refraction
acknowledge
correction?
whether or not you can do an angle correction from a bent line, because according to you, the horizon you're correcting this from
Oh,
is
disagree
a
with that.
bent, refracted horizon. You're not acknowledging it. You're asking me something.
Why should I acknowledge that?
Because
Just
you're
like-
saying we're doing dip correction from this bent line. That's why, you stupid idiot who can't keep up with the conversation.
Why would that be a problem?
Why would it be a problem to correct an angle from a bent line? Because bent lines don't give you angles. Are you stupid?
Why not?
Why don't bent lines give you angles?
Yeah.
You're stupid, mate. You're fundamentally retarded.
Do you say what?
You're
Well,
fundamentally
how
retarded,
lines
my
work,
friend.
how
If you
curved
can't
wheels
understand
work,
why a
if
bent line doesn't
there's
give you
no-
an angle, there's no helping you, you're mentally retarded. This is a problem. You're stupid if you think bent lines require angle corrections. They're not straight to correct from. Do you not understand that? Do you think that bent lines need correcting when they're not straight to give you angles? I'm asking you, you're just not answering.
I understand, absolutely, I understand your argument.
Right, so when you say you're dipping, so when you say you're doing a dip angle, shut up. Now the conclusion comes now you've finally conceded your stupidity, that bent lines don't give you angles to correct from. When you say you're doing a dip angle correction from a bent line to a refracted horizon, that makes no sense. Because you can't correct an angle from a bent line to a horizon that is not a straight line geometric horizon. It's refracted, according to you.
Well, you should say so.
No, that's what you said.
No, I say you should say so about the part in which you can't have the angle from a curved line.
No, you can't. Are you retarded? Do you really think you can get an angle from a bent line? We're back to this stupidity, are we, Dumbo? No, mate. No. I'll just correct you. You don't need to interrupt. No, mate. Bent lines won't give you an angle. You stupid idiot.
So lenses wouldn't exist?
Sorry, you think I need to know about lenses? Do you think that a bent line can give you an angle, retard?
It obviously can, because...
So therefore your bent line to a non-geometric horizon won't manifest a dip angle correction, will it? Hello? Are you stupid or deaf? Hello?
You're just not addressing my answer.
Your answer, what? That you've got a bent line that's going to manifest an angle correction? No, that's retarded, because bent lines don't give you angles. You're telling me I'm not addressing your argument? Yeah, I am, directly.
You're denying my
Can we have him
now
define?
I'm trying to support it, and you're not addressing my answer.
Sorry, you want to support that a bent line can give you an angle?
Yes.
Okay, go ahead.
Yes. Yes, this is how lenses work. This is how curved mirrors work. So when you have lenses have curved surfaces, right? If they didn't have, they wouldn't magnify, or they wouldn't do what they're supposed to do. And the way a lens is designed is based on how the angle of the light ray is going to change when it crosses the surface, which is curved. What tells you that it is Snell's law. It talks about two angles: the angles in which the light ray reaches the surface, and when it leaves the other side, refracted. Those two angles are to the surface, and the surface of a lens is curved. So if you couldn't have an angle to a curve, how would lenses work? How could you apply Snell's law to a lens? Or even mirrors. Mirrors, the angle of reflection and the angle of incidence are the same.
Curve, you dickhead.
Yeah, you can have curved mirrors, and that's the law of reflection still apply. And it still talks about the angles to the surface of the
shut up. Order in the court.
Thanks. 10th. Tell him one more time, please.
From a curve,
you're breaking up. I think Nathan has...
Shut up!
Yeah, it's because you won't shut up, Bacon.
No, on Discord, your connection isn't... I think you have connection issues.
Silence!
Fucking...
Hang on, calm down. From a curve, I'll say it again. From a curve, elevation angle from a curve. Can you have that? Not to a curve.
What is the difference?
Well, you're standing with the sextant. You're standing measuring. You're measuring to the horizon. You're measuring to the horizon.
This guy's brain dead.
Yeah, the angle is between two lines.
You can't be serious, bro.
It doesn't matter which one is curved.
We're asking you if you can acquire an elevation angle measurement from a curved baseline.
Yeah, no, I'm not doing that.
An angle?
Sorry, no, you're not doing that. Mumble. No, you're not doing that because it can't be done. But we definitely do acquire and are acquiring elevation angle measurements in navigation. You just, when we get to this point last time, said, no, you aren't acquiring elevation angles, the ones that require a flat plane. Because you can't get them from a curved baseline. As he chants through the conclusion for a 5th time in a row. You scared of this, mate? Because that's the 5th time you've chanted through the conclusion as I've made it. 5th time. Does it scare you? Last time we got to this point, you made clear that you weren't talking about an elevation angle measurement at all. That's what navigation requires. Now, you can't acquire one. It's the 6th time he's interrupted this conclusion. It's terrifying. You can't get one from a curved baseline.
Yeah, the straw man is that I wasn't referring to measuring the elevation angle directly.
So you're not referring to it like we give two shits what you're referring to. It's used in navigation. Do you think we give two shits what you personally are doing here? Navigation requires the acquisition of an elevation angle measurement from the ground you are standing on to navigate the ground you are standing on. It uses the horizon, the best thing we can get to establish horizontal, and then we get the angle from the plane we are establishing. Now, that's a flat earth requirement. Every time I point this out, you say, well, I'm not explicitly acquiring an elevation angle. Like we give a shit. You're a nobody. This is the method of navigation, nobody, not what you think you need to do. Do you understand now?
Well, I think the way I understand works, because I've tested it.
You've tested it. Meanwhile, navigation is done using elevation angle measurements. You acquire a flat baseline by way of the best thing you can use to get it, which is the horizon in this instance, according to you. And then you establish that baseline as flat to get an angle from it. Now, none of that involves a curved surface at all. Now, maybe you'd like to tell me again for the 4th time that you're not doing anything with elevation angle measurements. Meanwhile, celestial navigation requires them. It's how the Earth is navigated. You use sextants to establish the Earth as flat to get an angle from it.
Yeah, it didn't say I'm not doing anything with an elevation angle. That's the straw man I'm referring to.
The straw man for you, or the navigation method that's used to navigate the Earth as flat? Because we don't care what you're doing. Navigation uses a flat Earth.
Then why are you asking me? Because
why are you defending it? Do you think you can get an elevation angle measurement from a curved baseline? You can't. Earth is flat.
Concede.
I mean, I don't get it. Do you want to know my answers or you do not? Because your guys start asking me questions, and when I try to answer, you say you don't care about what I say.
All right. How'd you get an elevation angle measurement? How'd you get an elevation angle measurement, as done in celestial navigation, for finding your way along the ground that you immediately diverted away from last time we had the conversation? Because you're obviously willing to talk about the ground that's navigated when you tell me that we're not navigating the ground. We're not referencing the ground. That's what you told me last time. So what, you think you're reasonable, do you, mate? No. Last time we had this conversation, you made it explicitly clear that we weren't talking about the ground. Yeah? So when we talk to you as an individual, you're not talking about the same subject that's being debated. That's navigation and the acquisition of elevation angle measurements by way of the best thing possible to establish a horizontal baseline. That'll be the horizon according to you. But then you tell us we're not talking about, or you're not using or utilising elevation angle measurements. That makes you a wanker. You understand now, wanker? Yeah, we are trying to debate navigation and how it uses flat Earth elevation angle measurements, but then you seem to think that you're not talking about them when we talk about them with you. And are you going to get one from a flat baseline that is required, or a curved Earth that isn't being used or described when you describe acquiring horizontal from the horizon? Yeah? So we're kind of talking about the same thing until you fail and can't bear to concede, then suddenly you're not talking about elevation angle measurements, are you? Yeah, we are. Until you lose. You want to tell me I'm using a straw man again?
Yeah. But it's kind of pointless trying to clarify.
But that's my straw man. It's pointless trying to clarify the straw man you claim I'm using and haven't defined or justified or given an example of how I'm using a straw man, or how I'm using a claim you haven't made to burn in lieu of one you have, when we're not talking about a claim you've made, we're talking about how celestial navigation is done, not what you've claimed. I'm not making up something that you haven't claimed. We're discussing celestial navigation here, how it uses a flat plane. Do you understand that now?
I mean, sort of pointless keep asking the questions, and when I try to clarify my answer, it just...
just bleat about how you haven't had an opportunity to debate here, when you've rumpused the shit out of my conclusion about the horizontal plane that we established with the best thing possible, the horizon, and you tell me that we're not talking about elevation angles. Yeah, it's just you're not getting a chance to clarify when you deny the very thing we're discussing. That would be elevation angle measurement. You said it wasn't that. Or the ground that we're navigating. You said we weren't talking about the ground. No, you're just an unreasonable wanker who denies the very thing we're discussing and then claims you haven't had an opportunity to debate and then interrupts me when I summarise how unreasonable you've been in claiming we're not talking about the ground. Do you recall telling me we're not referencing the ground? Do you recall that, unreasonable wanker? Because we were and are and definitely are discussing that if we are discussing celestial navigation. Maybe you think that we're talking about you, because we give two flying fucks what you think when we're discussing celestial navigation proving Earth is flat. Maybe we're strawmanning you and your claims of how navigation is done when we're discussing celestial navigation done on a flat plane with elevation angle measurements that require it to be flat. Maybe we're strawmanning you with that. When you just say you haven't had a chance to speak when I ask you to clarify the strawman claim you just threw out spuriously.
You'd also fail third grade geometry, by the way.
I've asked you to tell me what is the strawman that I have burned in lieu of an argument that you're making when we're discussing celestial navigation. It's not that you haven't had an opportunity. What's the strawman spurious claim?
Yeah, is then when I'm talking about whether I'm using or not using the ground? When I say we're not using the
ground? Whether or not you are using the ground?
Oh,
sorry, Mr. High-Pitched! Celestial navigation uses the ground.
Yeah, we use.
Yeah, so we're not talking about you and what you do. If you're referencing the ground, you complete clown, celestial navigation uses the ground. So it seems that when you tell us what you're doing, you're strawmanning us because celestial navigation does use the ground. So, in fact, your claim of strawman is actually you strawmanning us with something that doesn't use the ground when celestial navigation uses the ground. So you're actually strawmanning us.
Yeah.
I didn't even say what the strawman was. I mean,
sorry, strawman would be you burning an argument that we don't make. Right? Well, if we're not discussing what you do when you reference a non-ground, that isn't an argument we're having. We're talking about celestial navigation. So it seems you want to burn an argument that you would have about how you wouldn't use the ground. That's not what we're debating. Therefore, you're burning something we're not debating. That's the definition of a strawman. So you're now projecting your strawman use onto me, aren't you? Yep. We're not discussing your use of the ground or non-use of the ground. Celestial navigation, as conceded a moment ago, does use the ground. So when you argue for an argument that doesn't require the ground, that's you strawmanning us. Okay? I take your silence to mean you now understand that your projection of your strawman that you want to use when you discuss something that isn't referencing the ground when we're debating navigation of the ground, that's actually a strawman you want to use. Hello, I'd like to get a response from you. You've claimed I'm using a straw man, and then you've told me how when you talk about something that isn't referencing the ground, blah, 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 aka straw man, we're not arguing about. That's you using a straw man and claiming I'm straw manning you. No, I'm not.
You know what a straw man is?
Yeah, I was trying to answer that. So, I wasn't trying to say that we're not using the ground. I just said that...
Sorry, you weren't trying to say that when you specifically said that you weren't needing to reference the ground. Now you're telling me that you're not saying that you weren't needing to reference the ground when you very specifically told me that you didn't need to reference the ground. You lying turd. So, lying turd, you weren't saying that you didn't need to reference the ground when you very specifically told me that you didn't need to reference the ground. That wasn't what you were doing. Yes, it was. You're just a liar. Bacon's a liar. He's lying about what he did and didn't claim when he specifically said he didn't need the ground to reference. He's saying he didn't.
He did, I heard him.
Yeah, we all heard him. He's just a lying sack of shit claiming I'm using a straw man when I'm not. He's straw manning us with his non-use of the ground when that wasn't being debated, projection of his own straw man straight onto me, and then continual fundy muting and rumpusing as I pointed out.
Nathan, when you're done, give me a minute.
What did you say I said? Well, I'm on echo too. What the...
Dude, could you at least be honest with yourself and with us and just say, yeah, my bad, that's what I did. And then maybe we can move on, right? We're not going to go anywhere unless you accept that that's what you did. You strawmanned us because you came into the discussion talking about something we weren't talking about, right?
I was trying to answer
Because we were talking about celestial navigation, which uses the ground. So if you came in and said that you're not talking about the ground, well then who's at fault? And then you charge Nathan with a straw man.
Chocolate, if you're done, I'd like to ask him.
Yeah, go ahead, man.
Thank you. Okay, look, with all due respect, you went right to a bubble sextant when we started talking. Did you or did you not?
I'm sorry, what was the question?
I said when we started talking about the sextant and elevation angles, you immediately went to a bubble sextant. Did you or did you not?
Not immediately, no.
Okay, but did you say bubble
because I want to
sextant?
clarify a point.
To be fair,
Please.
To be fair, that
Did you
was
say-
after he said he was lost and didn't understand. So
Okay, so
He's
did
the
you
first
s-
person to bring
Okay,
the word
please.
up.
Guy in Discord and Alwyn. Go ahead, 10th.
The guy in Discord and me, please, just 2 minutes. I won't need much more if he can respond quickly. Did you or did you not say that a horizontal is what you were going with from the bubble sextant, not using the Earth's horizon? Did you or did you not refer to that? Yes, no?
If I refer to the bubble sextant not using the surface, is that what you're asking?
Do you even remember what you said? So when you said you have a horizontal at your eye line, how did you get it? I'll ask it that way.
When I mentioned the bubble sextant, I was asking if you added up the angle from the bubble sextant to the nautical sextant.
I'm asking
that would add
you.
up to
I'm
90.
asking you, since you know about the bubble sextant. This is very painful. Does the bubble sextant need the Earth's horizon to establish a horizontal, or does it use the artificial horizon that the bubble gives it as a horizontal to the eye line so that you can establish vertical, like you said?
Yeah, use the artificial horizon and with the
Thank
bubble.
you.
Yeah.
Thank you. Thank you. Thank you. So now, if you found yourself contradicting yourself, you would admit it, right? I mean, if you realized you were making a contradiction and no one was making fun of you, you would admit your contradiction if you made a mistake like we humans always do, correct?
Of course.
Okay, so since you use an artificial horizon with the bubble sextant to create an artificial horizontal to get 90 degree and a zenith, if that can be coincided exactly using the Earth's horizon with a Mariner sextant after height of eye correction, wouldn't that make the two the same?
Yes. That was my point,
Thank you.
actually. That,
Okay, perfect. Okay, hold on, perfect. Thank you.
He's
Hold
upper
on.
swindling you.
No, hold on. Nathan, please go to Master B, and it's the last two slides, but go to the written part. And someone posted in Discord so he could see it.
None of you listen to his original claim.
Brian, please.
Oh, where is it?
Please. It's going to come your way.
1 second.
It's labeled sextant altitude corrections.
I got you. Hold on a second.
Thank you, Kiwi.
I'll let you know when it's posted. 1 second.
Perfect. Nathan, if you could put in Master B, then everyone else could see it.
It's up.
There you go. It's in Discord at 12 minutes after the hour.
Okay, here we go. Sextant altitude corrections, page 419, Practical Navigator, I believe. Thus, it applies only when the visible horizon is used as a reference and not when an artificial horizon, either internal or external to the sextant, is used. It applies to all celestial bodies. If the eye of the observer were at the surface of the Earth, visible and sensible horizons would coincide and there would be no dip. Do you understand that so far?
Yeah. Yeah,
Okay.
I'm with you.
Okay, so then the visible horizon, once corrected for height of eye, is matching the horizontal from the artificial horizon from the bubble section. It's the same horizontal. You do admit to that, right?
Yep, that's right.
Okay, perfect. So let me read on. This is never the situation on board ship, however, and at any height above the surface, the visible horizon is normally below the sensible horizon, as shown in figure 1605A. Normally, then, an altitude measured from the visible horizon is too great and the correction is negative. It increases with greater height of the observer's eye. Because of this, it is sometimes called height of eye correction. You follow what I'm saying so far?
Yep.
Okay, Nathan, go to the next slide, which is the picture. And Huey, if you can throw that one to him.
It's already there.
Okay, perfect. So let's look at this. Let's look at this picture. It shows the sea. It shows some land and a tower or a mountain, whichever you like. And let's say you're on top of that instead of the sun or this light thing. Let's say that's you up there with a bubble sextant. You've got your artificial horizontal at eye line, right up there. And then you look at the sea horizon, as far as you can see, and that's your line of sight to that. Dip correction is height of eye above sea level. So you bring that thing down. Now these two coincide. Do you see that?
Yeah, I understand it.
Okay, you know what that's called? Angle of depression correction. So the Earth's surface is horizontal to match the artificial horizon, horizontal. So that means the Earth is flat. And that means the only thing you corrected was your angle of depression, whether you're above the ship that you took it or on this peak. And an elevation angle is two straight lines. All angles are two straight lines, but it's a right angle that you got to minus. Why do you think you minus from 90 degrees once you get your angle?
Because you want to use your zenith angle.
Oh, thank you. So can you have a 90-degree angle on a curved surface?
Yeah.
Oh my gosh.
Hold on.
Wow.
No, you
Oh,
can't.
I rest my case. I rest my
Hold on.
case.
You said
And
yes.
compute.
Hold on. You said yes. Kind of 90 degrees. Okay. No wonder I got frustrated with you. I went through it several times with you, and at one point you conceded. Bent lines meeting straight lines don't give you an angle.
I didn't concede that, did I?
Sorry. So
If I did,
sorry.
I must have misspoke or
Let
something.
me clarify then, may I? You're saying that a bent line meeting a straight line can give you an angle.
Yeah.
That's wrong.
Can you show
You
us
say
that?
so?
Would you like to define an angle for us, please?
Oosh, that's don't remember the definition on the top of my head, but I can look at what Wikipedia says.
Yes, please. Yes, please. Bearing in mind, we'll clarify as you look that your last statement was that a curved line meeting a straight line is an angle. Let's see if that meets the definition of angle then, shall we?
Right. In Euclidean geometry, an angle is the figure formed by two rays called the sides of the angle, sharing a common endpoint called the vertex
Sorry,
of the angle.
stop a second. My bad.
Angles.
Sorry, my bad. I asked for a definition of an angle.
Oh, it's saying here. An angle is the figure formed by two rays called the sides of the angle, sharing a common endpoint called the vertex of the angle. Angles formed by two rays in the plane that contains the arrays. Angles are also formed by intersection of two planes. These are called dihedral angles. Two intersecting curves might also define an angle, which is an angle of the rays lying the tangent to the respective curves at their point of intersection. So according to this
What's
first
a
paragraph
ray?
of Wikipedia, two intersecting curves may also define an angle. So I feel like I'm justified.
It described a
Is a
tangent.
ray
So, it described a tangent,
sorry.
though, didn't it?
Yeah, this is how you define the angle between two curves. It's the same angle you find with the tangents.
But you don't have that, do you?
Why not?
So you told me that the line to the horizon was bent.
Yeah,
So do you not understand what a tangent is?
I do.
Is it a bent line?
No,
So you don't have that then?
you do. It's the direction that the sextant's citing. That's the
So
tangent.
you
to
told me that was the
specified
horizon, and I
refraction
asked you if that was refracted. You said yes. Do you not understand that refracted means deviated from straight? That's not a tangent.
Yeah, but that's not exactly how you measure.
It's not a tangent.
You're measuring with the
It's
sextant,
not
right?
a tangent, is it?
At the sextant, it is.
So,
Because the sextant only
sorry,
have two
sorry.
directions.
The sextant, according to you, is looking at the horizon, and according to you, that's refracted. So no,
Yeah.
according to you, it is not a tangent. So you do not have a tangent to a curve.
The line
Do
of the
you?
sextant is
You
tangent.
seem to be talking through the conclusion
You
again. It's
have.
back to this me asking if you're scared when I get to conclude my statement. According to you, I'll repeat, I'm almost certain you'll interrupt halfway through. According to you, the line to the horizon, which is what you look at through your sextant, has a bent line to it. That's what you stated. Now you're saying that you can get a tangent to a curve, but you don't have one because your line to the horizon is not a tangent. It's a bent line deviated from straight, refracted according to you. That is not a tangent.
Yeah, you're right when you say that that curve is not a tangent. which
Right,
is-
so you don't have a tangent then. In your description, you described a tangent to a curve, and with the sextant on a globe, according to you, you don't have that. Do you?
You do. You do.
Sorry, no, you don't. You've just conceded that it's a straight line, and your line to your horizon, according to you, is refracted. That's deviated from straight. That is not a tangent.
Okay, so you claim the opposite and tell me to concede. Like, can I support my argument or my claim?
No, you can concede that when you tell me the line to the horizon is deviated from straight, that a deviated from straight line will not be a tangent. You can concede that before we move on.
No, I want to support my point. I don't want to.
You want to support that a bent line can give you a tangent? Because that's where we're at. You've said the line to the horizon is a bent line, refracted, deviated from straight. Now you're describing how you can acquire a tangent to a curve. When asked how you can acquire an angle for an elevation from a curved baseline. Your citation describes a tangent to a curve. You don't have that.
Yeah, my answer is you do at the sextant.
Sorry, from the sextant, you're looking at a refracted horizon. That's not a straight line to a tangent point. It's a bent line, according to you. So just telling me that you have got a straight line because you're now using a sextant and it isn't refracted, it's a straight line to the horizon. Well, why did you tell me it was a refracted, non-geometric, bent, refracted line earlier on?
I'm sorry, it doesn't make any sense for me to be in this discussion.
So it doesn't make sense. You're telling me that it was a bent line refracted to the horizon earlier. Now you're telling me that when you look through a sextant, it's a straight line to form a tangent. That doesn't make sense.
Well, thank you for the other guys that were trying to engage. That was nice. So yeah. To clarify what I mean by the dip.
So
And
dip
see
from
if we
what?
can
So,
agree or
dip from-
disagree on-
dip from what?
Of the horizon.
From the
Yeah,
horizon?
the thing apparently you
from
don't
the
believe-
horizon?
Yeah.
From the horizon. And is the horizon capable of deriving an angle from, i.e. it's geometric with a straight line to it, or is it refracted?
Yeah, it is refracted.
Well, then refracted means deviated from straight. You're not going to be correcting any angles from a deviated from straight line. That would require a straight line. So if the horizon's refracted, why are you correcting dip from it? It's not a straight line to correct from.
Yeah, but that's not exactly how you measure.
It's not a tangent.
You're measuring with the
It's
sextant,
not
right?
a tangent, is it?
At the sextant, it is.
So,
Because the sextant only
sorry,
have two
sorry.
directions.
The sextant, according to you, is looking at the horizon, and according to you, that's refracted.